Hello students, no music today. This is video 5.3. Unit title is polygons and quadrilaterals, and the objective is I can determine whether a quadrilateral is a parallelogram. So today basically is very similar to yesterday. However, we are going and using the converse. Remember the converse? Where we change P and then Q. We switch them. So we start off with if P then Q. We're starting off today with if Q then P. All right, and you're going to understand what I mean by that when we get started. So let's get started. This definition for parallelogram you wrote down yesterday. This is basically what we're changing, okay? We're flipping anyway. A quadrilateral with both pairs of opposite sides are parallel. We know that, we see that. But now we're going to start off with, say we start off with a quadrilateral with certain specific skills, then it then becomes a parallelogram. So that's what we're actually going to work towards. So let's begin. All right, so the useful theorems that we're going to start with are going to be here. Here's the first one. You are writing this down. If both pairs of opposite sides of a quadrilateral are congruent, then, so here is a quadrilateral. I'm going to draw. And it says opposite sides are congruent. That means this side is congruent to this one, and this one is congruent to this one. Then it's a parallelogram. So you should be adding this statement to that first part that you wrote. So that is an if-then sentence. If-then. Make sure you have that down. The next one is if an angle is a quadrilateral, if an angle of a quadrilateral is supplementary to both of its consecutive angles. So here's our quadrilateral. And you've got two angles on the inside. Here we go. Here is A and B. And if we can prove that A and B are a total of 180, so that would mean that you'd have a statement that said A plus B equals 180. If this is true, then this figure is it is a parallelogram. Okay, so we're basing this on given information. The next one says, if both pairs of opposite angles of a quadrilateral are congruent, then here's my figure, and I'm going to put in, here's my quadrilateral, excuse me, and this angle here is 55, and this one is also 55, then hey, these would have to be 125, 125. So the opposite angles are congruent. So this then is a parallelogram. Okay? On to the next one. If the diagonals of a quadrilateral bisect each other, well, they bisect each other if we can actually show that the two pieces created from being cut are congruent. So if this piece is 4, and this one is 4, and this one is 8, and this one is 8, then that shows clearly that this is now been bisected, and this is a parallelogram. Parallelogram. All right, we're on to our examples. Can you prove that the quadrilateral is a parallelogram based on the given information? So for A, if we look at the figure, we see that we have 4 sides opposite that are all congruent, okay? So again, if you have at least 2 sides that are opposite and congruent, you have a parallelogram. And since we have all the sides are congruent, that is at least true that we have 2, so this is yes, a parallelogram. Okay, and our reason is because we have 2 pairs of sides congruent. 2 pairs of congruent sides. B. B says, well, look at the picture. All we can see in B is that we have these 2 segments that are congruent. Okay? It looks like this has been bisected here, but the other diagonal doesn't tell us anything. A parallelogram has diagonals both that have been bisected. But since both haven't been bisected, we can't say this is a parallelogram. So the answer is no, sir, because this only has one diagonal that's been bisected. Last but not least is C. And C here, just want to erase that yucky mark there. Okay, so C here shows me that it looks like I've got opposite angles congruent here and here, and here and here. And that definitely is parallelogram. So yes, opposite angles congruent. Okay, so here is our final problem, secret hot question. It says, think about a plan. BC is parallel to DA, and BC is congruent to DA. Prove ABCD is a parallelogram. How can drawing diagonals help you here? And how can you use triangles in this proof? Okay, so good luck, and I'll see you tomorrow. Don't forget to record your secret hot answer in the Google Doc later.